All right, let's dive into something straight out of science fiction, except it's real. We're talking about brain-computer interfaces. This isn't just a far-off future concept anymore. It's happening in labs right now, and we're going to break down exactly how it all works. I mean, come on, who hasn't? The idea of just thinking and having a drone fly or a message appear on a screen, that's the dream, right? Well, that's pretty much the entire goal of what we're exploring today.
Okay, so what is a BCI, really? In simple terms, it's a direct line from your brain to a machine. Think about it. Right now, your thoughts are translated by your hands typing on a keyboard. A BCI, well, it just skips that middleman entirely. It lets the brain speak its own language, those little electrical zaps, directly to our tech.
So yeah, this is way more than just a cool party trick. It's about building the ultimate bridge between what we think and what we can do with technology. Let's get into the nuts and bolts of how that bridge is actually constructed. Now, if you're sitting there thinking, wow, that sounds incredibly complicated, you're absolutely right, it is. But it's not magic. It all comes down to three huge, distinct fields of science that have to work together perfectly. These are the three pillars of BCI.
First up, you gotta have neuroscience. See, you can't just listen to the whole brain at once. It would be like trying to have a conversation in the middle of a screaming rock concert. It's just chaos. Neuroscience gives us the map. It tells us, hey, the thought to move your right hand, that creates a very specific spark right here in this part of the brain, so we know exactly where to listen.
Okay, so pillar 2 is the translator, artificial intelligence. Your brain is never, ever doing just one thing. While you're focusing on move left, you're also hearing a dog bark outside, you're feeling a little hungry. All of that is background noise. AI is the secret sauce. It's trained to sift through all that mental static and find that one faint signal for move left that we're actually looking for. And finally, you need the hardware itself, the electronics. And we're not talking about just any old sensors here. These things have to be sensitive enough to pick up on electrical signals that are thousands of times weaker than what it takes to power a tiny LED light. It's this hardware that actually catches those faint whispers from your brain and passes them on to the AI. So you see how it all clicks together? You can't have one without the others. Neuroscience tells you where the signal is coming from, the source. The electronics physically grab that signal, that's the bridge, and the AI figures out what it means, that's your translator. It's the complete recipe for turning a thought into an action. Okay, I get it. Neuroscience, AI, super-sensitive electronics, this is starting to sound like something you can only do with a PhD and a multi-million-dollar lab, right? But here's the amazing part. Once you understand that basic recipe, the ingredients to actually get started are, believe it or not, way more accessible than you think.
Seriously, anyone can start this journey. First, you just learn the basics of EEG signals. That's the non-invasive way to listen to your brain's rhythms using a simple headband. Then, you can actually buy a consumer-grade sensor, hook it up, and use freely available code to program your first command. It could be as simple as making a cursor on your screen move just by focusing. You could do that.
And what's so cool about this is that a simple project you build at home, it's not just a toy. It's literally the first step on the exact same path that leads to the most advanced, groundbreaking BCI research in the world. And here's how that path actually scales up. When you're starting out, your goal is just to learn the ropes, right? You're using simple tools to make something that works, a proof of concept. But that's the seed. Official research just takes those exact same core ideas and uses them to create brand new knowledge for humanity. The fundamental skills, they're identical. All that changes are the tools you're using and how big you're dreaming. So, look at that. We went from BCI seeming like this impossibly futuristic idea to breaking down its core parts, and now to seeing a clear path for literally anyone to get their hands dirty. The future of this tech, well, it's inside all of our heads. This really brings us full circle, doesn't it? The whole point of this was to answer this exact question, and now we know the answer. You get from a weekend project to real research by mastering those three pillars: neuroscience, AI, and electronics, using projects you can build yourself. That path from being curious to being a creator is clearer than it has ever been before. So, we'll just leave you with this. The building blocks are out there, the path is laid out, the potential is, well, pretty much limitless. So the only real question left is, what are you going to create with your mind?